In recent months, the Sun has been exhibiting unusual behavior, puzzling scientists who are closely monitoring solar activity. Solar storms, unpredictable solar cycles, and the potential for the Sun's magnetic field to flip have raised concerns about the risks to our civilization. Understanding these changes and the possible consequences is crucial, as we are currently in the midst of a solar cycle that could bring us a magnetic storm on the scale of the Carrington Event of 1859. At the heart of the concern is the Sun's magnetic field, which is created by massive convection currents. These currents induce and deduce forces, ensuring that the Sun's extremely hot solar material is constantly in motion. The Sun's magnetic field, in turn, determines which particle currents, also known as solar winds, hit Earth and at what intensity. Solar winds shape Earth's climate, and while these plasma currents are essential for life by warming the planet and enabling vegetation, they can also be destructive. The last major solar storm of this magnitude occurred in the 19th century, and it paralyzed the then-young power supply for days. Today, our society is vastly more dependent on electricity, and a solar storm of similar scale could have far-reaching consequences. The Carrington Event of 1859 was a massive solar storm that disrupted telegraph systems across the United States and other parts of the world. At the time, telegraphs were the cutting-edge technology, comparable to modern smartphones. The plasma ejection from the Sun overwhelmed Earth's magnetic field, causing widespread communication failures. Auroras, normally seen only near the poles, were visible as far south as the Caribbean. The Earth's magnetic field usually protects us from excessive solar radiation by capturing and deflecting charged particles. However, during the Carrington Event, the particle density was so high that the magnetic field's protection was compromised. This allowed large amounts of charged particles to penetrate deeper into the Earth's atmosphere, resulting in widespread auroras and disruptions to electrical systems. Today, our civilization is far more dependent on electricity than in 1859. If a similar event were to occur now, the effects would be catastrophic. Imagine waking up to find that your refrigerator, coffee machine, and communication systems no longer work. The sky might be lit up with colorful auroras, but beneath the beauty lies a serious threat to our infrastructure. Without electricity, hospitals, airports, ATMs, and supermarkets would face critical failures. Airplanes might lose navigation systems, and satellites could be knocked out of orbit. Researchers are constantly monitoring the Sun, looking for signs of solar storms that could potentially affect us. Recently, they have observed changes in the Sun's behavior that are cause for concern. The Sun's magnetic field is highly dynamic and constantly changing due to the turbulent forces within its interior. Unlike Earth's relatively stable magnetic field, the Sun's magnetic currents are in constant flux, leading to unpredictable plasma ejections. These ejections, when they hit Earth, can disrupt electrical and communication systems. While the Earth's magnetic field protects us from most solar radiation, there are limits to its protective abilities. When solar storms reach a certain intensity, as they did during the Carrington Event, the magnetic field can become overwhelmed. This leads to disruptions not only in electrical systems but also in satellite communication, air travel, and power grids. Scientists study the Sun's activity using solar cycles, which are periods of approximately 11 years during which solar activity waxes and wanes. We are currently in the midst of a solar cycle expected to peak in 2025, but recent events suggest that the Sun is behaving more unpredictably than scientists had previously thought. In the spring of 2024, a large sunspot appeared, leading to violent solar storms that created visible auroras as far south as Hawaii and Australia. These storms caused power outages in some regions and disrupted Elon Musk's Starlink satellite network. If this activity is a precursor to even more intense storms, the peak of the solar cycle could bring unprecedented challenges. The study of solar activity and its effects on Earth has advanced significantly since the Carrington Event, but there are still many unknowns. While scientists have made great strides in predicting solar storms, their models are based on a relatively short period of detailed observation. Much of the data comes from computer simulations and historical observations using early telescopes. This reliance on simulations means that predictions are not always accurate, and recent solar activity has defied expectations. In 2003, the Halloween solar storms were detected only minutes before they hit Earth, illustrating the limitations of current forecasting methods. One of the biggest fears is that a massive solar storm could hit without warning, causing widespread damage. While scientists believe that sunspots and other indicators will give them enough notice to prepare for such an event, the sun's unpredictability makes it impossible to be certain. A solar storm of the magnitude of the Carrington Event or greater could cripple our electrical grid, knock out communication systems, and lead to widespread panic. With airplanes in the air, hospitals relying on life-saving equipment, and a world dependent on digital technology, the stakes are much higher today than they were in the 19th century. Another potential danger comes from the sun's magnetic field itself. The sun's magnetic field undergoes periodic flips, which can disrupt solar activity and lead to increased solar storms. If a flip or collapse of the magnetic field were to occur, it could cause massive solar eruptions and send intense streams of charged particles toward Earth. While scientists argue that such flips are a normal part of the sun's activity, they cannot predict when or how they will occur. A sudden and extreme change in the magnetic field could lead to devastating solar storms, possibly more destructive than anything we have seen before. In recent years, the sun has shown signs of behaving in ways that do not fit the typical solar cycle model. The sunspot that appeared in 2024 and the violent storms that followed were unexpected, and researchers are struggling to reconcile these events with their predictions for the 2025 solar cycle peak. If the sun continues to defy expectations, we may be in for even bigger surprises. Scientists reassure the public that they are closely monitoring solar activity, but the truth is that much of what happens on the sun is still a mystery. Solar flares and storms can form and hit Earth in a matter of minutes, leaving little time to prepare. While researchers are confident in their ability to predict major solar eruptions, the sun's unpredictable nature means that there will always be an element of uncertainty. The risks to our civilization are real, but the timing and severity of the next major solar storm remain unknown. With the peak of the current solar cycle approaching, it is more important than ever to stay vigilant and continue studying the sun's behavior. As we look ahead to the future, we must be prepared for the possibility of a solar storm that could disrupt life as we know it. Understanding the sun's cycles and monitoring its activity will be critical in mitigating the damage caused by these powerful forces of nature. While we cannot prevent solar storms, we can take steps to minimize their impact on our technology-dependent world. The Carrington Event of 1859 occurred when society's dependence on electricity was minimal, making the disruptions comparatively limited. However, today's world is built on a highly interconnected digital infrastructure that relies on satellites, power grids, and wireless communication systems. The consequences of a Carrington-level solar storm today would be far more severe, potentially leading to catastrophic global impacts. The modern electrical grid, for example, is far more extensive and interconnected than the primitive systems of the 19th century. A massive solar storm could induce currents within the power grid, causing transformers to overheat and fail. Unlike the relatively isolated power outages we experience today, a solar storm could trigger widespread and long-term blackouts across entire continents, taking weeks or even months to fully repair. Additionally, many of the satellites orbiting Earth, used for communication, GPS, and weather forecasting, are vulnerable to solar radiation. A direct hit from a solar flare could disable satellites, cut off global communication, and disrupt aviation systems. Airplanes could lose their navigation capabilities, and air traffic control systems could fail, forcing emergency landings in hazardous conditions. As we approach the predicted peak of the current solar cycle in 2025, the scientific community is on high alert. The unusual activity observed in 2024 suggests that the sun's behavior may be more erratic than previously thought. While researchers are monitoring the situation closely, they remain cautious about making predictions regarding the magnitude of upcoming solar storms. As we continue to uncover the sun's secrets, one thing is clear: we must stay vigilant. The sun's unpredictability could impact our world in ways we can't fully anticipate. Will humanity be ready when the next mega solar storm strikes? Stay tuned for future updates as we keep a close eye on the sun. Don't forget to subscribe, like, and hit the notification bell to stay informed about this cosmic journey.